Hello, this is Elijah Peters. This is week 10 of Data Structures and Algorithms. This week is on trees, and this specific tree assignment has three different assignments in one. So this is all under one file to make organization and readability a little better, specifically for the DOT files that would be then turned to PNG files with our graphics software. So let's get into it. This file starts with the import of the Java IO file writer, so we can write over the DOT files, and we can later on use those to put in commands in the terminal to use our graphics software. So let's get into this first. So in this class is on node structure, the tutor family tree, the prime number binary search tree, the level order traversal routine on those trees, and a method to generate the graphics DOT files near the end. So getting into this, the node structure for both trees is that structure right there. It's left to right level order, so it would go down to levels left to right, node to node. And the tutor family tree starts off with we generate the DOT file for the tutor tree, and we traverse it, like I said, level by level, left to right, node to node, and then we start with the primary or the prime number binary tree, which is 0 to 100. And then we make an insertion that creates a skewed imperfect tree, which we'll fix later to make it look a little better, even though it would be skewed because the both sides of the tree are not equal. So these generations are not equal with two kids on one side and two kids on another side. There would be 2 to 1, which would make it skewed. And then we have we generate the DOT file for the binary tree, the second generation of the tutor tree, which is left child to right child pattern, and the generation 3, which it's the same pattern before, left to right, child to child. And these two implementations, we have a simple binary tree representation for the PNG file readability. So we go over the tree again, the tutor family tree, and then we create the binary search tree by inserting prime numbers. We get down here, we inserting prime numbers. The prime numbers are between 0 and 100. We have a helper function to insert new nodes to the tree. If the integer is comparable, we use its natural comparison with the if statement. And then we get down to the traversal routine, which is left. We go left order traversal, so level by level, left to right, node to node again. We use a queue. And for the first search, we list to store the traversal results. We use a list to store the traversal results. We process children from left to right, and we output the result in the format that is needed to have the DOT files. We generate the DOT language string and save it to the file, and we use the Gravits software that generates the visual representation of the tree structure. We then use a queue for traversal to process all nodes and edges. Then we use the sanitize ID for spaces and names to make sure the tree structure is readable in the PNG and the DOT files. And so we define the node labels, and we define the edges in those. And the edges are labeled R for right to next, specifically in the binary tree. And we also have left, or L and R for left and right for the tutor tree as well. But then we write the DOT code to the file, another helper function to fix the node IDs for the graphics software, and we then remove the spaces and the special characters at the end with that final sanitize ID method. And that is week 10. Oh, actually, no. Let's go over the PNG file for this. So we have the prime or the PNG file, the binary tree or the binary structure tree, and we have goes 2 to 3, and then R for R, and it keeps going down the prime numbers. We have the let's get back to this. Let's get back to this. We get to the tutor tree, and we see that it starts with Henry, and we go down to his predecessor left and goes under that family side and goes to Margaret Tudor and goes down to Mary Tudor and goes to Edward to Mary and then also down to the last generation child, which is Elizabeth. We have left and right to sort those out, and it's as nice as it can be as a skewed tree. And that is week 10.